Okay, so hello guys. So welcome to our new lesson. So second sem, new lesson, and new subject, new lesson. Okay, so I hope guys that um, all of you are doing good. And for today, we will be discussing electric charges and electric fields. So some of you will be thinking, oh, so now we will be entering the um, electrical charge stage. Okay, so electrical engineering stage. Okay, and some of you will be thinking that we will be entering the electronics engineering stage. So yes, now we will be entering the stage where higher level of general engineering will be discussed in here, which involves the electricity, not particularly the electrical engineering side, but a higher basic engineering, general engineering topics and uh, subjects. Okay, so first topic is we have the electrical charges and electric fields. Okay, so for this we will be discussing first the electric charge. So as you all know, we have two types of charge. Well, we have three, but we will be focusing on the two because the third one is the neutral charge. So now we will be focusing on the two charges, which is the proton and the electron. So we all know that the proton is the positively charged particle and the electron is the negatively charged particle. Hindi naman pwede maging positive at positive yan. So the charge should be positive and negative. So that is the proton. So so proton is a positively charged particle while the electron is the negatively charged particle. And I want you to note guys that the neutron is the neutral charged particle. Okay? So both charges have an equal amount of charge, meaning the net electric charge is zero. Meaning kapag parehas yung proton and electron ng charge, pag nagsama sila is magkakaroon tayo ng neutral charge. Okay, so the net electric charge will be zero. Okay, so sir, why did you say that both the proton and the electron has the same charge? Okay, so they have the same charge, they have the same value of charge, but they just differ from the sign. Okay, so what do you mean by the sign? It is the charge, meaning positively charged and the negatively charged particle. Okay, so both of them have a value of 1.6 times 10 raised to negative 19 C. What is that C, sir? That is the coulomb. That is the unit for our charge. It is not a unit for charge, but it is the unit for coulomb. Okay, so 1.6 times 10 raised to negative 19 coulombs. Positive for proton and negative 1.6 times 10 raised to negative 19 coulomb for electron. Okay, so I hope guys that uh, you won't get confused with these two. Okay, so always remember negative charge, negative 1.6 times 10 raised to negative 19 coulomb for electron and positive 1.6 times 10 raised to negative 19 for the proton. Okay? Okay, so let's proceed to our law of conservation of electric charge. Okay, so this is the same as our energy. A net electric charge can never be created, but charge can move from one place to another. So both of our energy and our electric charge cannot be created. It can only be transferred from one point to another. Okay? So that is our electric charge law of conservation. Okay? So if you're going to be confused, always remember also the same as our energy. It cannot be created. It can only be transferred from one point to another. Okay? So, I have a quick question. Aside from being a good conductor of electricity, what is the difference of a conductor and an insulator? Okay, so I'll give you guys time uh, to think or to generate answers. Okay, so and please try to check if your answer is also similar to mine. Okay. Okay, so do you have answers, guys, for our question? So, aside from being a good conductor of electricity, what is the difference of a conductor and an insulator? Okay, so we have here an answer. So, a conductor have charges that can move around freely. Those charges are negatively charged, meaning too many electrons moving around. Okay, so insulator has missing electrons. So that is the difference between the two. A conductor has charges moving freely, positively charged and negatively charged. And they have too many electrons running around. And while our insulator has missing electrons. Okay? Missing electrons, it can be no electrons or minimum amount of electrons to begin with. So that is the difference between the conductor and the insulator. So scientific basis or on the scientific side, when you check for the electrons on an insulator, for example, of wood, so there are missing electrons or there are minimum amount of um, electrons in there. Okay, so guys, I want you to focus on this because I'll be discussing something. So let's say this is a copper rod, or let's say this is a conductor. Okay, why, sir, are you going to discuss what's the difference between a conductor and an insulator in this? Yes, I'll be discussing this. Okay, so let's say this is a copper rod, or a conductor. Okay, so this conductor, when we talk about conductor, when it comes to connecting charges, there are positive charge outside our conductor. So as you can see, we have positive charges in here. So these positive charges tends to connect to our conductor to transfer a flow of electricity. Okay. So with this, our conductor has negative charges and also positive charges. That's why when we discuss about this, there are positive and negative charges roaming around. Okay, roaming around. Okay, when we talk about conductor, when the positive charges moves and make a contact to our conductor, what will happen to our conductor. Okay, so scientifically speaking, when the charges makes contact to our conductor, they will be moving first to our electrons. Okay, when I say move first, they will be attracted to uh, our electrons. Okay? And when it happens, pumunta yung ating positive charges sa ating conductors, what will happen is other charges will tend to move out. Those other charges are the positive charges. Okay? Those are the positive charges, those are the protons, will move out. Okay? So, sir, why? Because in a conductor, if there are positive and negative charge will just stay in there and welcomes all the positive charges that will be coming inside. Okay? And sir, what will happen next? What happens next is those and the other positive particles will flow out of our conductor. That's why there will be a continuous flow. So the next time meron pa ulit group of positive charges outside, yung mga pumasok naman kanina, sila naman yung lalabas. Okay, as you can see, we have six charges. We have six charges na nag-enter. We have 6 charges na nag-enter. And also, meron din tayong 6 charge na lumabas. What comes in also must comes out. And that is why conductor is a good conductor of electricity. Once the positive charges comes in and the negative charges welcomes them, the other positive charges will move on to the next location. So that's why electric charge cannot be created. It can only be transferred from one place to another. Okay? So this is our representation of a conductor. When a positive charge landed on our conductor, other positive charges within our conductor tends to move out. Okay? So, sir, how about our insulator? So as you can see, we have wood in here, and this wood contains protons. Okay, so this would contain protons. So sir, may charge po ang ating, meron pong charge ang ating wood. May electrical charge, yes, pero they won't be able to be a good conductor for the reason that our insulator has a missing electron or electrons. Okay, so we have positive charges outside and that will be coming inside our insulator. So when they move in here, so as you can see, they will be moving inside our insulator. This phenomena will be impossible. This will be impossible. Okay, so sir, why is it impossible? For the reason that there is no electrons, there are missing electrons, meaning no one will welcome our protons. So there won't be any attraction. If there won't be any attraction, what will happen to our protons? They won't be able to come inside to our insulator. That's why our insulators don't conduct electricity because there are no electrons to welcome our protons inside. Okay, so sir, you're talking about welcoming, entering. Is there any possibility that the electrons will be also moving to our protons? So in some cases, there are cases that our electrons tend to be attracted to our protons. So in that cases, for example, mas mabigat yung ating object na merong proton kaysa doon sa ating electron. For example, a sweater and the balloon. So try to rub the the balloon to our sweater, and you will see that the electrons on the balloon will be attracted to our sweater. Okay. So in this case, the positive charge will not be attracted to our insulator because the insulator don't have any positive and negative charges. Okay. So, sir, you're talking about welcoming entering. So, our proton and our electron has a movement. Okay, so before we discuss those movement, electric charge is a property that causes an electrical phenomena when placed in an electric field. Okay, so electric charge is a property that causes an electrical phenomena when placed in an electric field. Okay? So we have methods of electric charge. We have friction, contact, polarization, and grounding. So when it comes to methods of electric charge, when we charge particles or when we charge an object, we have these types of charges. Friction or yung rubbing ng ating cloth ng kung kayo gumagamit ng blanket, most of our electrical charges can be obtained through friction of our skin to our blanket. Okay, so you will see friction. So kung may blanket ka tapos tumutulog ka, may maririnig kang mga lumalagi-lagitik dyan. Those are some of the frictional charges na nagkakaroon na nag-o-occur sa ating uh, sa ating sa ating kumot. So that is electric charge. When we say contact, normally this can be seen through our appliances. Okay, so kapag nagsaksa kayo sa ating AC, when it comes to running our appliances, when you want to watch TV, so you have to plug it in so that there is a contact in electrical charge. Okay, there will be contact that the electricity will pass through to our um, pass through sa ating plug, and then it will be able to run our televisions. Okay, so polarization, when it comes to polarization, we will be ionizing. Okay, so polarization, it's a method of moving our proton and electron manually to an to a metal or to any conductor. Okay, so this is a higher application, and it's normally done if an object don't have any proton or electron. Okay, so when it comes to grounding, that this is the last. Grounding is when you put an overcharged rod or any electrically charged um, object. When you put it into ground, or you tend to bury it into the ground, electrons will come out, and that is our electrical charge grounding. Okay, so there is a transfer to from our rod to the earth. That is grounding. Okay, so next. So as you can see, we have here arrows going inside sa ating electron and arrows going out sa ating proton. Okay, so the explanation in this is this is what I'm talking about a while ago. When you say that the electrons welcomes all the protons, this is what I'm trying to say. Our electrons have the capability to receive charge. Okay, that's why our electrons has a capability to welcome the protons. Okay, while the protons don't have the capability to welcome electrons, but they are the ones that giving themselves or giving the charge away. So si proton yung lalapit kay electron. As you can see that the proton has an arrow that moves forward to the electron, while the electron has the arrow that they will be receiving all the charges. Okay? So I hope guys that this is clear to you. So yan, we have here a formula for finding the electrical force. We have F or force is equivalent to K Q1 Q2 all over R squared. So we have here our K, our constant, which is 9 times 10 raised to 9 Newton square meter per Coulomb square. Okay, so per Coulomb square. Okay, so this is known as the Coulomb's law. That's why, as you can see, we have our charge in here that is based in coulombs, because this is an what do you call this? And this is a discovery by Coulomb. Okay, so force exerted by two charges on one another is directly proportional to the product of the charges and inversely proportional to the square of distance between the two charge. Okay, guys, take note. I will be reading this again. Force exerted by two charges, which is Q1 and Q2, on one another is directly proportional. F is equals to Q1, Q2, directly proportional to the product of the charges, Q1 and Q2, and inversely proportional. Inversely proportional because they are because our uh, the distance or r is our radius inversely proportional to the square of the distance between the two charge. Okay, so if you want to remember our Coulomb's law, just refer to our formula. F is equals to K Q1 Q2 all over R squared. Okay, force exerted by two charges on one another is directly proportional to the product of the charges and inversely proportional to the square of the distance between the two charges. So meaning we will be always when it comes to electrical force, there should be two charges. Okay, electrical force F has two charge Q1 and Q2. Okay. So let's try to have an example here. So two electrons apart from each other has a distance of 3 micrometer. Solve for the magnitude and direction of the charges. So I'll be giving you guys time to solve this one. And let's try to solve this one later. Okay, so I'll be giving you guys time. Okay, guys, so do you have any answers to our um, problem? Okay, so if wala, let's give this example a go. Okay, so we have here our given, which is electrons, two electrons, negative E is equivalent to negative 1.6 times 10 raised to negative 19 coulomb. Okay, so negative 1.6 times 10 raised to negative 19 coulombs. And we have radius of 3 times 10 raised to negative 6 meters. Microcoulomb, uh, negative 10, 10 times times 10 raised to negative 6, that is micro. Okay, and we have our K, our constant, electrical constant, 9 times 10 raised to 9 Newton square meter per coulomb. And we will be solving for uh, our force, electrical force, and the direction of the charges. Okay, we have here our solution, which is F is equivalent to K times Q1, Q2 all over R squared. F is equivalent to 9 times 10 raised to 9 times negative 1.6 times 10 raised to negative 19. As you can see, we have here square. We have here a square. Okay? So, if we have here a square, meaning we have used the two electrons. Okay, so we have two electrons, and that's why we will be giving here a square. So, kung hindi naman, pwede nyo siyang paghiwalayin, dalawang negative 1.6 times 10 raised to negative 19. Divided by 3 times 10 raised to 6 square. Square of the charges. Okay, we have here square, and that's why we will be putting a square in here. So, we have here a value of F is equivalent to 2.56 times 10 raised to negative 17 newtons. Okay, so since the value is positive, meaning the electron charges repel one another. Okay, so how will you say that they repel to one another, sir? So if there is a positive charge, if it is a positive force, meaning there is a repel action. Okay, repel action to from the two charges. Okay, if there is a negative value, meaning there is an attraction, because negative multiplied to a positive will be negative charge, meaning there is an attraction to each other. If there is a positive force, meaning those two are going on a distance. Okay, they will be distancing themselves to each other. Okay, if there is a negative charge, if there's a negative force, two charge will be moving, attracted towards each other. Okay, so we have here our force of 2.56 times 10 raised to negative 17. So let's try to solve this one. 9, okay, so wait, 9 times 10 raised to 9 multiplied to negative 1.6 times 10 raised to negative 19. Since dalawa sila, square all over 3 times 10 raised to negative 6. And this is in square. So, tama ba? Yes, okay. So we have here an answer of 2.56 times 10 raised to negative 17 newtons. Okay, so I hope guys na nakuha natin yung sagot natin. Okay, so let's proceed to our next slide. Okay, so like charges repel while opposite charges attract. That's why we have negative force if there will be an attraction. So hindi pwedeng magkaroon ng attraction kapag positive yung ating force. Okay? Okay. So like charges repel, opposite charges attract. So positive, they will be moving out. Negative and negative, they will also be moving out, but positive and the negative charge will be attracted to each other. Okay, I hope you get what I'm saying in here. So electric fields. So what are electric fields, sir? So electric fields, an electric field is a measurable effect generated by any charged object. So magkakaroon tayo ng electric field whenever we enter an area where electricity is present. So it is a measurable effect generated by any charged object. For example, in a power plant. So as you can see, that's why they are advising our other people to keep out, for the reason that um, there is a high probability that a person will be struck by lightning or electricity when you enter an electric power plant or yun dun sa mga poles, dun sa maraming poste. Okay. So, because electricity in that electric field is very much present. So, okay, we have charges in electrical field. We have the point charge and we have the test charge. So, test charge tends to be smaller in value in our electrical field. So, if you want to test if there will be electrical field, so try to put a little bit of a charge in there, a little bit of charge, and that is what we're calling test charge. And on a certain point in our electrical field, that is what we call our point charge. Okay, so point charge is represented by capital Q, and the test charge is represented by small letter q. Okay, so in order to know the value of the electric charge, we will be having our formula. Electrical field is equivalent to force over Q, or our test charge. Okay, so our force in here is Q all over R squared. So since, as you can see, we have here our test charge multiplied to our point charge for our force in here. Same formula pa din. It's just hindi na lang siya parehas test charge. One of them is point charge and one of them is test charge. But the unit is still the unit of the force is still in newtons. The unit of our test charge and our point charge will be the same, coulombs pa din. Okay? Okay. So substituting the value of our test charge, the value of our force in our formula, we have here electrical field is equivalent to K test charge multiplied to our point charge all over R squared will be all over Q, or our test charge. As you can see in here, we can cancel our test charge. If we can cancel our test charge, we will be having a formula of our electrical field of E is equivalent to KQ over R squared. And we will be having a unit of our electric field of Newton per Coulomb. Okay? So this is the unit of our electrical field. Okay? Okay, so here's the formula. E is equals to KQ all over R squared. Okay, so positive electrical field, our positive charge is moving towards our certain point in our electrical field. Okay, while our negative electrical field, our charge point is moving to our neutron, or our electron. Okay, so our point is moving towards our negative charge, while our positive electrical field has a tendency to give charge to our electrical point. Okay, so we have here our formula, which is E is equals to KQ all over R squared. Direction towards the point, while our electrical negative electrical field is having the same formula, E is equals to KQ all over R squared. Direction is approaching the charge. Okay? Okay. So hindi ako nakapag picture ng aking simulation para maipakita ko sa inyo that in a certain point in electrical field, when you place an object or an electrical charge, the positive electrical field will be receiving. They are the ones that they are the ones that giving out the charge. That's why the direction is in towards to the point. While in the electrical field, it is the point are nearing to our electrons. So mixture of positive and negative. Okay, so negative distance to a point in a field and the positive distance point in a field. So we have here our electrical field net, which is positive positive electrical field plus negative electrical field. Okay. So we have here the direction of our positive towards the point, and our point is moving to our uh, electrical negative or our negative electrical charge. Okay, so we have your positive electrical field is equivalent to KQ all over R squared, and we have negative E is equivalent to KQ all over R squared. Okay, so we will be solving for this para mas maintindihan natin. Okay, so negative 200 microcoulomb and a positive 300 coulomb is placed 1 meter to the right of the negative charge. Solve for the magnitude and direction of a point if a point is placed 30 centimeters to the right of the positive charge. Okay, so we have so we have here our illustration. Okay. Yeah. So here's the illustration, and we have our given. So if you can, or if you can solve for this, please try to solve for this, guys. And we will be discussing this after quite some time. Okay. So please try to solve. Okay, so let's try to discuss this one. So let's discuss this. Okay. So as you can see, we have our electrical point in here. Yan. Okay. So our positive charge will be moving towards our point, and our we have a positive 300 microcoulomb charge, and we have here a negative 200 microcoulomb charge that the point is moving towards our electrical to our negative charge. As you can see, there will be a a difference of movement of our point. So as you can see, our point is our positive charge is moving to our point while our point is moving. And it's magulo masyado. Pero hindi. Hindi yan magulo. Okay? So let's try to solve first our positive charge. We have here our positive E is equivalent to KQ all over R squared, where we can get our positive electrical charge of 30 times 10 raised to negative 6 Newton per Coulomb. So we have here 9. Okay, so wait. 9 times 10. So we have here 9 times 10. Okay, so 9. Oh, so 9 times 10 raised to negative 9. Multiply to our positive 300 times 10 raised to negative 6 all over 0.3 square. So we will be having a 30 times 10 raised to 6 Newton per Coulomb. While our negative charge for our negative electrical field will be having a negative E, which is 9 times 10 raised to 9 and negative 200 times 10 raised to negative 6 all over 1.3 square. Okay, sir, why is it 1.3 for that? Eh, ang atin naman po ay 1 meter lang po. 1 meter away sa ating positive charge, yung ating electron, and additional 30 centimeters para dun sa ating point. That's why it is 1.3. And we will be having an answer of negative 1.6065 times 10 raised to 6. Okay, so what will happen, sir, next? We will be using our E net, which is positive E plus negative E. So if it is positive E and negative E, so we will be doing this. Okay, so we will be having a 30 times 10 raised to negative 6 plus negative 1.065 times 10 raised to negative 6. We have here 29 or 28.94 times 10 raised to negative 6. Okay, so we have here negative 6. We have here negative 6. So there's a type, tama ba? Oh, 6 pala. Tama, tama. We have here, wala pala siyang negative sa ating exponent. So we have here 28.94 94 times 10 raised to 6 Newton per Coulomb away from the charge going to the right. Okay, so what do you mean by that, sir? So our point pala is moving away. Ang direction ng ating point is ang ating charge will be approaching our point. Okay, mas malakas yung attraction ng ating proton kaysa sa ating electron. Okay, so our charge will be moving away. So we have here electric flux naman. So electric flux, phi E, this is read as P H I or phi. Okay, that is phi or phi. So that is phi E is the electric field lines that pass through a certain shape or area. So for example, sa bilog na ito, may magpapass through dito na electric charges. Okay, so that pass through a certain shape or area. For example, we have here a square. So this is not a trapezoid. So nakahiga lang siya. That's why it looked like a trapezoid. So in here we have an imaginary line. This is the electric flux, and this is the green arrow is the direction the direction of our electrical field lines. Okay, so we have here our surface area. That is the one that's passing through. We have here the electrical field line. And here is our normal line. So as you can see, makikita ninyo, yun yung dinadaanan ng ating electrical field line. So Gauss law, the electric flux phi E is directly proportional or equal to the charge enclosed in a surface area. For a given area, there will be a certain charge, and ang electrical na ang pag-pass through niya doon sa ating surface area is perpendicular sa kanyang surface area. So kapag nakalapat siya sa lupa or nakalapag siya, diretso pataas naman yung ating our electrical charge. Okay? So based on our drawing, makikita ninyo dito yung pag-pass through ng ating electrical charges or electrical field line doon sa ating surface area, perpendicular. That's why we have here our blue line here. This one is to indicate that this is a perpendicular in angle sa ating electrical field line. Okay, so next, move on tayo to our next. We have electrical flux. We have here our phi E, which is equivalent to Q all over permittivity of free space, or this one is what we call the epsilon. Okay, so phi, electrical flux, this is the unit Newton square meter per coulomb. We have the charge C, and we have the permittivity of free space, or our epsilon, which is 8.85 times 10 raised to negative 12 coulomb square per Newton square meter. So as you can see, nabaliktad lamang ang ating unit. Nagkaroon lang tayo ng square dito, and the placement is C squared all over nm squared for our permittivity of free space, and the electric flux has a Newton square meter per coulomb. Yun lang, guys. So yun lang yun. And let's try to expound this more. We have our phi E or our other formulas. We have electrical field and our surface area. We have E is equals to KQ. This is the derivations, guys. KQ all over R squared, and our A is equivalent to 4 pi R squared. Cancel natin yung ating R, yung ating radius natin. We have K is equivalent to 1/4 our K in here. We have 1/4 pi epsilon, and we can cancel out our 4 pi, and we will be having the remaining Q all over E. That's why we have our electrical flux is equivalent to Q all over epsilon. Okay? Okay, so please try to remember that our formula here is phi E, or this one is the electrical flux. It's equivalent to electric charge all over our permittivity of free space. Okay, so please try to copy this one, guys, and we will be moving on to the next. Okay, so let's proceed. So we have here our formula. If in the event our electrical field line has an angle, we have here our uh, formula. We have here EA cos alpha. We will be measuring our angle in with respect to our y-axis. We will be not in here, but in here. Okay, in our alpha. Okay, so let's try to solve for this one. A horizontal disk that has a 3-meter diameter has flux passing through it with 30 degrees from the horizontal. Solve for the electrical flux if it has a value of 100 Newton per coulomb. So we have here our radius of 1.5 degree of alpha, which is 60 degrees, and E of 100 Newton. So guys, why did we use 60 degrees? As you can see, passing through a 30 degrees from the horizontal. From the horizontal, guys, this is the horizontal passing through the horizontal of 30 degrees. If this is 30, meaning this one is 60. And we will be using our cosine alpha in the uh, in the uh, vertical side. Okay, not on the horizontal. Okay, not in here, but in here. Okay. Okay, so don't be confused by that. Okay, so let's try to solve for this. Yan yung ating itsura. Okay, so electrical field line, electrical field is equivalent multiplied to our area. So that is our electrical flux. Okay? Okay. Okay, so EA cos alpha. So we have here our electrical flux of 100 Newton per coulomb times pi 1.5 square cosine 60. What do we get? Do we get 353.43? So we have here our 100 Newton per coulomb, and we have 1.5 square multiply to our pi cosine 60. And yes, we have 353.43 Newton square meter per coulomb. So we have here our electrical flux of 353.43 Newton square meter per coulomb. Okay? So lastly, we have okay, so lastly, we have an example of the electric flux through a sphere of radius 4 meter that contains a plus positive 50 microcoulomb and B negative 50 microcoulomb as its charge, as its center. Okay, so we have here 50 times 10 raised to negative 6. That is our charge. And 8 all over 8.85 times 10 raised to negative 12. So here is our constant, 8.85 times 10 raised to negative 12. We have here our value of our first charge, which is the A, 50 microcoulomb. We will be having an answer of 5.65 times 10 raised to 6 Newton Newton square meter per coulomb. So 50 times 10 raised to negative 6 all over 8.85 times 10 raised to negative 12. So yeah, that is our 5.65 times 10 raised to 6 Newton square meter per coulomb. So that is for the A. And for the B, so magiging negative lang naman yung nasa taas natin. And we will be having a negative electric flux, which is negative 5.65 times 10 raised to negative 6. Raised to 6. Okay, so is that it? Let's see. Same lang sila. Okay. So that's it, guys. We finished our first lesson. Medyo mahaba siya. We have the electric field. We have the electric charge, electric field, and the electric flux. I hope, guys, that you all do well. You all will do well. And I, yun, we finished our first lesson. And do you have any questions? If you have any questions, don't hesitate to raise your hands after this presentation. I hope, guys, that everybody's okay, and congratulations on arriving here. In physics too. So some of the students tend to lose their way, finding the way to our second sem. But thank you, guys, na nakaabot kayo. So konti na lang, and graduation is upon you, guys. Okay? So if you have any questions, just raise your hands, and I'm gonna end my presentation now, and I'm not gonna consume your time any longer. So thank you, guys, for attending. Oh, wait. Okay, so thank you, guys, for attending, and I hope to see you sometime. Okay, so that's it. Thanks for this. Bye, guys.